What does it take to build a home on the moon? Not only is space construction one of the most extraordinary challenges humanity has faced, it might just be the answer to some of the biggest problems we're facing here on Earth. In the next decade, NASA plans to establish a permanent human presence on the moon. By 2030, lunar bases could be up and running, with Mars missions following just a few years later. However, building in space comes with a fundamental challenge. Sending materials from Earth is astronomically expensive. It costs around $1 million per kilogram to launch materials into space, let alone the moon or Mars. To put that into perspective, imagine shipping a brick into space for the price of a luxury car. To build a habitat on the moon, we simply can't rely on Earth's resources. So how do we build homes, habitats, and even factories on the moon without breaking the bank? The answer lies in lunar regolith, the moon's surface soil, composed of a mixture of fine dust, sand, and small rock fragments. This material is already abundant on the moon, and in recent years, engineers have been working on a revolutionary idea, 3D printing using regolith. Dr. Patrick Suermann and his team at Texas A&M University are leading the charge in this area. They've developed groundbreaking techniques to use 3D printing technology to build structures on the moon, using regolith as the primary building material. By processing the moon's dust, they create a material capable of being layered into complex structures. This eliminates the need for costly shipments of traditional building materials from Earth. The process of lunar construction begins with mining the regolith. While the moon's surface is covered in dust, beneath that is a mixture of small rocks and particles, which are rich in valuable compounds like silicon, iron, and oxygen. These compounds can be processed into building materials. 3D printers, using advanced techniques, can use the regolith and binders like polymerized sintering to build structural elements. Essentially, the regolith is heated to a molten state using high-powered lasers or focused sunlight, allowing it to be shaped into bricks, walls, and other building components. This method of utilizing local materials drastically reduces the costs of construction, as there's no need to transport heavy materials from Earth. What's truly remarkable about this technology is that it doesn't require massive amounts of energy-intensive industrial equipment. Instead, it uses autonomous, solar-powered robots. These robots could construct habitats entirely on their own, building up layers over time, creating both the structure and any tools needed for subsequent construction. By tapping into the moon's natural resources and employing 3D printing, we're not only solving the problem of high transportation costs, but also creating a sustainable method of construction that could be used on both the moon and Mars. These autonomous robots could work 24/7 without the need for human intervention, making the process incredibly efficient. While building on the moon might seem like a distant goal, the technologies being developed for lunar and Martian construction are already beginning to have a profound impact right here on Earth. One of the most promising applications of these technologies is disaster relief. In areas affected by natural disasters, such as earthquakes, hurricanes, or floods, traditional construction supplies may be hard to come by. That's where 3D printing can make a dramatic difference. Using local materials, 3D printers could rapidly create homes and infrastructure in the aftermath of disasters, providing immediate shelter and critical facilities for displaced populations. But it's not just about disaster zones. The potential for sustainable, low-cost housing in remote or underserved regions is enormous. By using locally sourced materials, whether it's lunar regolith or Earth's abundant earth, we can dramatically cut down on the costs of transporting traditional building materials. In fact, several companies and research teams are already experimenting with 3D printing using Earth-based materials like concrete, clay, and recycled plastics to create low-cost, eco-friendly homes. This method of construction could revolutionize housing in developing countries and help tackle the global housing crisis. Another key aspect of space construction is the role of robotics. In the vacuum of space, it's not just the material that's different. The entire construction process must be reimagined. Robots will be essential for both the mining of regolith and the building of structures. Autonomous robots and drones will be programmed to carry out tasks without human intervention, ensuring that construction can proceed with minimal risk. On Earth, this technology has already begun to transform construction sites, particularly in dangerous environments where human presence could be risky, like in nuclear decommissioning or high-altitude building projects. Automated construction also improves precision and reduces waste, contributing to more sustainable practices. As we push the boundaries of space exploration, we're inadvertently redefining how we think about construction on Earth. Technologies developed for building in extreme environments like the Moon and Mars can provide solutions to our Earth-bound challenges. In a world where housing shortages, environmental concerns, and economic instability often intersect, these innovations are paving the way toward faster, safer, more sustainable construction. By reducing the reliance on transportation and heavy machinery, these space-age techniques can make building more affordable and environmentally friendly. Dr. Patrick Suermann's journey from building bike ramps in Florida's Space Coast to leading cutting-edge space construction research is a testament to how space exploration drives innovation and how those innovations, in turn, shape our world. The work being done today is setting the foundation for a future where construction is not limited by location, material, or cost. The same technologies that will enable us to live on other planets will provide solutions to some of Earth's most pressing issues. As universities like Texas A&M continue to expand their space research programs, we're standing at the precipice of a new era in construction. The work being done today will not only help humanity live on other planets, but could redefine how we live here on Earth as well. These developments have the potential to transform not only the way we build homes, but how we approach sustainability, labor, and safety in construction. The technologies and techniques that were once confined to the realms of science fiction are now becoming a reality, and they promise to revolutionize both space exploration and life on our own planet. So the next time you look up at the stars, remember, the technology we develop for space could soon be the key to solving Earth's greatest challenges. With the rise of lunar and Martian construction technologies, the future of building is no longer confined to Earth. It's extraterrestrial, and it's happening now.